Good morning to one and all. I am Manasa, DL in Physics. So, today I am going to explain about lasers. Okay, the major topic is lasers. In that lasers, I am going to explain three subtopics. So, first one is the fundamentals of lasers. So, complete fundamentals of lasers, and next one is different types of lasers that we are having. And the third one is various applications where we are using the lasers in our daily life and different kind of industry. So, all the applications of lasers. So, in this video we will discuss all the three subtopics about lasers. Okay. So, first of all, what is meant by laser? What is meant by laser? So, that we will discuss first. See here, the acronym means abbreviation. So, the abbreviation of laser is the light amplification by stimulated emission of radiation. The total abbreviation or acronym of laser is light amplification by stimulated emission of radiation. So, first of all, in this case, in this laser, we are majorly using the stimulated emission process. So, before going to know about the stimulated emission process, first of all you need to know about the induced absorption and spontaneous emission, then finally stimulated emission. So, let us see. So, all the three processes are involved in the laser concept. So, in these three processes, the laser can be used only the stimulated emission process. So, first of all, before going to discuss all these things, so we need to know about who invented the laser first of all. So, laser was invented by the Albert Einstein, okay, one of the famous scientist Albert Einstein. He used the photon concept to explain the photoelectric effect. So, in that case he discovered the laser concept. Is having dual nature. So, dual nature means light is having wave nature and also light is having the particle nature. This is called wave particle duality. This will be explained by de Broglie. So, de Broglie concept of matter waves. Okay, the complete wave particle duality of a light can be explained by the de Broglie, and de Broglie concept of matter waves. In that case, the de Broglie explained all the concepts of wave particle duality. Okay. So, before going to explain about laser, so first of all we need to know about measure. Measure means M-A-S-E-R, measure. So, measure means microwave amplification by stimulated emission of radiation. So, this measure was given by the scientist. So, this measure was given by the scientist Charles Townes. So, in this picture we would able to see the scientist Charles Townes in the year of 1951. So, 1951 measure was invented by Charles Townes. Okay. So, he used the ammonium to explain about the measure concept. He used the ammonium material. He used the ammonium molecule to explain about measure, which is almost about the wavelength of 1 centimeter. Okay, 1 centimeter. By using this device, he amplified the microwaves, because the name itself measure. Measure means microwave amplification of stimulated emission of radiation. Okay, he used this measure to amplify which waves? To amplify the microwaves. Charles Townes used the measure concept to amplify the microwaves by using ammonium molecule in the year of 1951. Okay, this is the story about measure. Okay, next coming to the, so in this slide we can able to see the measure. So, initially it is a measure and it is a microwave amplification by the stimulated emission of radiation. Okay, to amplify microwaves of wavelength 1 centimeter, he used the ammonium molecule. So, in the previous slide we have seen the Charles Townes picture. Okay, that is what the measure concept. So, see. So, now I am going to explain about the basic concepts of laser. Okay, basic concepts of laser, what are the? Absorption, that is induced absorption, and next one is spontaneous emission, next one is stimulated emission, and after that population inversion, lasing action. So some of the major concepts that include to understand the laser concept very easily. Okay, to understand the laser concept very easily, you have to know some keywords. Okay, those are the keywords which are able to using to understand the laser concept. So what are those? Induced absorption. So first one is induced absorption. See what is induced absorption. Okay, see here, induced absorption. So in this case, induced absorption means, see the first picture. So see the first one, induced absorption. So in this induced absorption, this is the energy level E1. Okay, so see here in the first picture, induced absorption, this is what induced absorption. So the energy level E1, so in the ground state, the atoms are occupied, the more number of atoms are occupied in the ground state, and the ground state is more stable state. So whenever we are giving energy, this is what the energy h nu, E is equals to h nu. Whenever we are giving some energy to the atoms which are in the ground state, they are excited to the next energy level, that is what? Energy level E2. For example, this is energy level E1, this is energy level E2. Okay, so whenever you are giving some amount of energy to the ground state atoms, they will simply move to the next state of energy. That state of energy is called excited state. Okay, this is what? Ground state. First energy state is what? Ground state. This is what? Ground state, and this is what? Excited state. So whenever we are giving some energy to the atoms which are presented in the ground state, they are excited to the next higher energy level. That higher energy level, here we can call it as excited state. Okay, so this process of transferring atoms from ground state to excited state is called induced absorption. So the process of transferring the atoms from ground state to excited state is called induced absorption. Induced absorption means the atoms which are in the ground state absorbs the energy, whatever the energy we are giving to the atoms which are in the ground state, that is called absorption. That is what? Induced absorption. Transferring the atoms from ground state to excited state. This process is called as induced absorption. Okay, Nana? This process is called induced absorption. Now coming to the spontaneous emission. The next one is spontaneous emission. Spontaneous emission means, so see here, spontaneous emission means what? Whenever the atoms which are in the, so the spontaneous emission means already the atoms which are moved to the higher energy state. That higher energy state is called excited state. Okay, so now the atoms are in the excited state. See here in the second picture, in the second box, see, so the atom in the excited state. Okay, the atom in the excited state, this is the atom which is present in the excited state. Now whenever the atom moves from ground state to excited state, the atom which is having certain lifetime, okay, after that lifetime, after the atom reaches that particular amount of lifetime, the atom automatically move to the ground state without supplying of any energy. So the atoms which are presented in the ground state, whenever you are giving energy to the ground state atoms, they are only moving to the higher energy level. But the atoms which are in the higher energy level, we no need to supply any energy to come to the ground state, because the atoms which are automatically moved to the ground state after certain period of time. So that certain period of time is called lifetime. So lifetime of that particular atom. So whenever the atoms which are presented in the excited state after certain period of time, they will automatically come into the ground state without supplying any energy to that atom. So that is what here spontaneous emission. So in this case, the atom which is in the excited state directly coming to the ground state without supplying any energy. But whenever the atom which is coming from excited state to ground state, excited state to ground state. It will release some amount of energy. It will release some amount of energy like this. We are seeing in this diagram. This is about the spontaneous emission. Now coming to the stimulated emission. What is stimulated emission of radiation? So this is very important concept which we are using in the laser. So laser abbreviation is light amplification by stimulated emission of radiation. So stimulated emission concept which we are using in the laser. See. Okay, see here, in case of stimulated emission, what will happen? So in case of stimulated emission, as it is, the atoms which are in the excited state coming to the ground state. So in this case, in case of spontaneous emission, we are not supplying any energy to the atoms which are in the excited state coming to the ground state. But in case of stimulated emission, so we are giving some incident matching photon of energy h nu. Okay, so here the atoms are in the excited state, so we are incidenting some photon of energy h nu on this the atom which is present in the excited state. So whenever we are giving some energy which is having h nu, then finally the atom which is in the excited state absorb that amount of energy whatever we are giving and coming to the ground state by releasing two photons of energy h nu. So this is what two photons of energy h nu. This is one photon of energy, this is another photon of energy. So it will release the two photons of energy h nu. This process of emission is called as stimulated emission, which is completely different from the spontaneous emission. This will be given by the stimulated emission process will be given by the Einstein. Okay, so this is what the radiative transition. Radiative transition means what, Nana? The radiative transition means whenever the atoms which are transferring from excited state to ground state, they will release certain amount of radiation. So that certain amount of whenever the atoms releasing the radiation, then that radiations are called radiative transition. Those transitions are called radiative transitions. For example, if we are transferring the atoms from excited state to ground state, then there is no emission of any energy or any radiation. That is called non-radiative transition. Okay, that is called non-radiative transition. Now one more thing here I want to explain you about the lifetime of the atom which is present in the excited state. The lifetime of the atom which is presented in the excited state is 10 to the power of minus 8 seconds. Okay, whenever we are sending atoms from ground state to excited state, the excited state lifetime is only 10 to the power of minus 8 seconds. After 10 to the power of minus 8 seconds, the atom automatically come to the ground state without supplying of any energy. After the atom reaches the lifetime, means after 10 to the power of minus 8 seconds, the atom automatically come to the ground state. So that is what about the lifetime of the atom which is in the excited state. Okay, so this is what about the three processes: induced absorption, spontaneous emission and stimulated emission. Now coming to the population inversion. Okay, now as of now we have explained about induced absorption, spontaneous emission and stimulated emission. Now coming to the fourth concept, that is population inversion. In general, population inversion means, so in our laser concept generally, so different kinds of energy levels are having by the different types of lasers. So now for example I am taking the ground state. So by comparing the excited state, by comparing the metastable state, so here I am introducing the new word metastable state that I will explain later. So in next coming slides. So first of all, population inversion. So the ground state containing more number of atoms when compared to the excited state, because the ground state is having the more stability when compared to the excited state. So that is why whenever the more stability, then more number of atoms are presented in the ground state. So in that case what will happen, the population inversion means achieving the more and more number of atoms in the excited state when compared to the ground state. For example, ground state is having 10 atoms, then excited state is having how many number of atoms in general? For example, maybe it is 3 to 4 atoms. This is also by supplying external energy to the ground state to transfer the atoms from ground state to excited state. Okay, but population inversion means achieving more and more number of atoms in the excited state when compared to the ground state. This is what ground state is having 3 to 4 atoms, but excited state is having 6 to 7 atoms, means achieving more number of atoms in the excited state when compared to the ground state. This is called population inversion. So the name itself explain you about the population inversion. Inversion means reverse, population means heavy. Okay, so ground state is containing less number of atoms, excited state is containing more number of atoms. This is what about the population inversion. So achieving more number of atoms, more and more number of atoms in the excited state when compared to the ground state is called population inversion. Okay, Nana, this is what about the population inversion. Next, coming to the lasing action. So the lasing action means in pumping process, which pumping process we are using. So electrical discharge pumping. So there are different types of pumping process are involved in the lasers. So that we will discuss in the types, in the various types of lasers. Okay. So this is what about the basic concepts of lasers. Now coming to the laser properties or the characteristics of laser light. So when compared to the ordinary light, the laser light is having some special characteristics. So what are those? One is directionality. Okay, so directionality and monochromaticity and coherence and brightness or high intensity and divergence. So these are the special 5 properties regarding to laser light. Okay, if you compare laser light with normal light, so these are the different 5 properties you are observing from normal light to laser light. So first of all, first point, that is directionality. Directionality means if you use a torch light one side and normal laser light another side. So the torch light is means what, Nana? The torch light produces the light in all directions, means there is more and more deviation when compared to the laser light. So laser light is having high directionality. So if you see this slide, you can easily understand. Okay, see, Nana. So this is what the laser light. So this is what the laser light. So whenever the light coming from the laser, this is having high directionality. Okay, and the light coming from the torch light is having high spreading nature. So that is why this is the the laser light is having high directionality when compared to the ordinary light. Okay, so this slide will give you the simple understanding of the difference between laser light, ordinary light or ordinary light versus the laser light. Okay. In the before slide, what we have understood the laser light which is moving always in a straight line motion without more deviation, without any deviation, not more deviation, without any deviation, the laser light moving in a straight line motion. So that is what about high directionality. Okay, the laser light is having high directionality. Now coming to the monochromaticity. Monochromaticity means what? So see here, mono means single and chromaticity means color. Okay, so the laser light which is emitting only single color. Okay, the laser light is which is only emits the single color, single frequency or single wavelength, that is called monochromaticity. The laser light source always emits only the single light, that is called monochromaticity. Okay, this is what the second characteristic of laser light. Now coming to the coherence. So the laser light is having high coherence. So see, in the next slide we will see about the coherence. So see here, the coherence light, this is what the coherence laser light, and this is what incoherence laser light. The source which is having the coherence laser light like this, and the light which the source which is having incoherent laser light, which is having the disturbance light wave, means the spreading nature is heavy. In case of incoherent LED light, the spreading nature is very less, that is completely zero. There is no spreading nature. The laser light, already I told you, in case of directionality, the laser light is having the straight line motion and which is completely any deviation. The laser light which is having no deviation, that is satisfying the coherence property. And the LED light means which is having incoherent property, that is why the spreading nature is heavy. Okay, see here, the spreading nature is very heavy. Here now coming to the fourth point, that is brightness or high intensity. Brightness or high intensity. Already I told you the laser light is moving in a straight line motion without any deviation. So that is why the brightness is very high when compared to the normal light. The laser light is having high brightness in nature, or this can also be converted as high intensity. Brightness or high intensity, both are same. Okay, and next coming to the divergence property. So the divergence property of a laser light. Divergence in general means what? Divergence means high spreading nature, but the laser light is almost the negligible divergence, means there is no spreading nature of the laser light. So that is why the laser light is having almost negligible divergence. So this is what about the different characteristics of laser light. Okay, now let us see normal light versus laser light. See, in this slide we can differentiate the light from ordinary light and laser light. So one side it is laser light and another side is it is ordinary light. So the laser light, already I told you, the laser light is highly monochromatic in nature, but when in ordinary light source, the ordinary light source which exhibits all the 7 different colors, that is VIBGYOR colors: violet, indigo, blue, yellow, orange and next red. So all the VIBGYOR colors are emitted by the normal light source, but laser light can emit only the single colored wavelength, that is monochromatic light. And when compared to the directionality, the laser light is having single direction, but in case of ordinary light, the ordinary light source emit the light in all the directions, which will spread in all the directions, but there is no spreading nature, which is having almost zero spreading in case of laser light. And coming to the coherence property, the laser light which is having high coherence in nature, but when compared to the ordinary light, there is no coherence property obeyed by the ordinary light. So this is what the major difference between the laser light and ordinary light. And next, Nana, continuation part. Next, the parts of laser device. So any laser device which will consisting of the following parts. So one is active medium, and another one is excitation mechanism, and third one is resonator. So whatever the device, whatever the laser device which is having the following different parts, what are those? Active medium, and next excitation medium, and next resonator. Now coming to the types of lasers. Okay, types of, what are the different types of lasers we are having? So lasers can be classified on the various different factors. Okay, on the various factors. So one is based on the active medium, lasers can be classified. Based on the excitation mechanism also, lasers can classified. Based on the laser output, so output also, basing on the output also, lasers can be classified. And based on the different energy system, different kind of energy levels also, we can classify the lasers. And basing on the wavelength also, we can classify the laser. So these are the different kinds of mechanisms which we can classify the laser types. Okay, so now see, let us see. So basing on the active medium, so first one is based on the active medium, we can classify the lasers into different types. So first one is solid state laser. So solid state laser, the example for the solid state laser is a ruby laser. Okay, so the ruby laser is a first solid state laser introduced by the Maimon in the year of 1960. Okay, ruby laser is a first solid state laser. And next, coming to the liquid laser. So liquid laser is a best example. The best example for the liquid laser is a dye laser. Okay, next coming to the gaseous state laser. Gaseous state laser, the best example is helium neon laser. And next is semiconductor laser. So basing on the active mediums, we can classify the lasers like this: solid, liquid, gaseous state lasers, and next semiconductor lasers. Now coming to the excitation mechanism. Basing on the excitation mechanism also, we can classify the lasers. So basing on the optical excitation mechanism, the example is optical pumping. So we are using optical pumping in case of ruby laser. Now coming to the electrical discharge pumping. Electrical discharge pumping process can be involved in case of helium neon laser. Now chemical pumping. Chemical pumping involved in case of chemical laser. Next, thermal pumping. So like this we can classify the lasers. We can classify the lasers by using the excitation mechanism. Next, coming to the final output. Basing on the final output also, whether the output is pulsed, means it is not continuous. Pulsed means it is not continuous. Basing on the final output, we can classify the lasers. So first one is pulsed laser. So the best example for the pulsed laser is a ruby laser. Next, continuous laser. The best example for the continuous laser is a helium neon laser. Okay, Nana. Next, basing on the level system. Level system means different kinds of energy levels also we can classify the lasers. So 2-level lasers. So 2-level laser means in this 2-level laser we are having only 2 energy levels, that is E1 and E2. So 2-level laser system is ammonia measure. Already we have discussed in the starting itself, measure microwave amplification by stimulated emission of radiation. So in case of measure we are using ammonium molecule, and this ammonium molecule can give the wavelength of up to 1 centimeter. By using measure we can produce the laser wavelength up to 1 centimeter. So that ammonium molecule measure is 2-level laser system. And coming to the 3-level laser system, the 3-level laser system is a ruby laser. Ruby laser we are using 3-level laser system. And next, in case of helium neon laser we are using 4-level laser system. The 4-level laser system can be used in which laser? Helium neon laser. 3-level laser system can be used in which laser? Ruby laser. 2-level laser system can be used in which laser? That is ammonium measure. Okay, this is what about basing on the level of the systems. Now coming to the basing on the wavelength. Basing on the wavelength also we can classify the lasers. Okay, so now visible region. If you see the visible region of the final output wavelength is equal to the visible region. Visible region means it's almost 400 nanometers to the 700 nanometers. The wavelength of the visible region is 400 nanometers to the 700 nanometers. Then that visible region is comes under the ruby laser. The best example for the visible region is ruby laser. Next, IR region. IR means infrared region. So the infrared region can be occurred in case of CO2 laser. Okay, CO2 laser we can able to identify the IR region in case of final output wavelength. Okay, and next to UV region, ultraviolet region. Ultraviolet region we can simply used in GaN laser. This is gallium nitrogen laser. Now coming to the microwave region. Microwave region, this can be used, this microwave region we can use the ammonium molecule. Ammonium molecule can be used in the measures. So that measure concept will give you, that is microwave region, that almost is the wavelength is in the microwave region. So that is why it is ammonium molecule. In case of ammonium molecule we can able to see the wavelength in the microwave region. So basing on the wavelengths also we can classify the lasers. Okay, these are the different kinds of regions which we can able to see different kinds of lasers. Okay, so next coming to the so the next concept is, now I am going to explain ruby laser briefly. So what is ruby laser? So the ruby laser is a first solid state laser given by the Maiman in the year of 1960. Okay, so the ruby laser is a first solid state laser given by the Maiman, okay, in the year of 1960. So in this case the host material is a chromium. Okay, chromium crystal, that is in this case we have used Al2O3 and Cr2O3. Okay, so in this laser we are using the lasing action, that is in case of ruby laser the pumping is optical pumping. So by using optical pumping we can able to transfer the atoms from ground state to excited state. The pumping action is a lasing action. Okay, by so in this case we are using the final output wavelength of the ruby laser is 6943 angstroms, or it can also call it as 694 nanometers. 694 nanometers. Now the pumping is what? Flash lamps or xenon flash lamps. So here we are using, in case of construction process of ruby laser we are using xenon flash lamp, helical xenon flash lamp. Okay, so the ruby laser is a 3-level laser system, 3-level laser system. So in this case the construction process involved, so see here the construction process of the ruby laser. Okay, so one side is a 100% reflective mirror, one side is a 100% reflective mirror and other side is partially reflecting mirror to get the final output. Okay, one is partially reflecting mirror, other one is perfectly reflecting mirror, completely 100% reflective mirror is one side and another side is partially reflecting mirror. And the ruby rod, ruby means light pinkish color, ruby is means what? The light pinkish color. The ruby rod is surrounded by the helical xenon flash lamp. The ruby rod is surrounded by the helical xenon flash lamp. Whenever you switch on this helical xenon flash lamp, the atoms means the light emits the photons. The photon of light incident on the ruby rod and the process will be done. Whenever you switch on the helical xenon flash lamp, then the photons which are coming from the light incident on the ruby rod, and finally the process will be done. So one side is 100% reflective mirror, another side is 95% reflective mirror, partially reflecting mirror, perfectly reflecting mirror, to get the final output wavelength. So the ruby rod, which by using the ruby rod we can get the final output wavelength is 6943 angstroms, very important. And this is what first solid state laser given by the Maiman in the year of 1960. Okay, the lasing action is what? Optical pumping. So here we are using the optical pumping mechanism. Optical pumping mechanism is used in case of ruby laser. So here the working. So previously we have discussed about the construction of the ruby laser. Now working of the ruby laser. So the active material in the ruby laser is a chromium ions. Chromium means Cr+3 ions. So the chromium ions, whenever the active material is a chromium ions in case of ruby laser. So in ruby laser, some of the aluminum ions is replaced by chromium ions, and these chromium ions only will give the pinkish color to the ruby laser. So only chromium, because of the chromium ions only the ruby rod is in the color of pink. Okay, first of all aluminum ions are replaced by the chromium ions, and these chromium ions, because of the chromium ions only the ruby laser is pink in color. So ruby laser is a three level laser. So E1, E2, E3. So whenever the xenon flash lamp is switched on means the light of photons which are emitted by the xenon flash lamp will directly transformed onto the ruby rod. So whenever the light of photon which are incident on the ruby rod, the process will begin. Okay, in this case what will happen? Whenever the xenon flash lamp is on, the light of photons which are incident on the ruby rod. Okay, so in this case whenever the light of photon incident on the ruby rod, the atoms which are in the ground state are excited to the higher energy states, and the atoms which are excited to the excited state, then finally after certain lifetime what will happen, that is the lifetime of the excited state is 10 to the power of -8 seconds. The atoms which are coming from excited state to metastable state. And what is the metastable state lifetime? Metastable lifetime is 10 to the power of -3 seconds. That is the excited state lifetime is 10 to the power of 5 times less than the metastable lifetime. Okay, so the atoms which are in the metastable state can stay longer time when compared to the excited state. Okay, when compared to the excited state, because the metastable state lifetime is more when compared to the excited state lifetime. So now finally the atoms which are from metastable state, by releasing the radiation, that radiation wavelength is, the radiation energy is 6943 angstrom. The radiative wavelength is, by releasing the wavelength, output wavelength of ruby laser is 6943 angstroms. The atoms are coming to the ground state. This is the process of involving ruby laser. This is the working process or working principle in case of ruby laser. The ruby laser. So the major concept, the major important topics which we need to remember in case of ruby laser is a solid state laser, and which was introduced by the Maiman in the year of 1960. And next, ruby laser is a 3-level laser system. And the output wavelength of the ruby laser is 6943 angstroms, and the ruby laser is in the color of light pinkish shade. Okay, these are the points which you have to remember in case of any entrance examination, and also you can remember these points. These are the key points to write in case of semester examinations, in case of theory examinations. Okay, this is what about ruby rod. Next, coming to the advantages and disadvantages of the ruby laser. So what are the advantages of ruby laser? See, So the advantages of ruby laser. So the ruby laser cost is cost effective because the cost is very low in case of construction of ruby laser, and the output wavelength in the order of in the order of 10 to the power of 4 to 10 to the power of 6 watts. Okay, and next coming to the solid state form. Okay, the ruby laser is a solid state form, that is why there is no wastage of material in the construction of ruby laser. And next, one more important point is the diameter of the ruby laser. The diameter of the output wavelength is very low. These are the advantages of ruby laser. Now coming to the disadvantages. What are the disadvantages of ruby laser? So here these are the disadvantages of ruby laser. So in case of ruby laser, it is very difficult to maintain the population inversion. It is very difficult to maintain the population inversion, and the output of the ruby laser is a pulsed laser. It is not continuous laser, it is a pulsed laser. And one more point is to move the atoms from ground state to excited state. So high power pumping is involved in case of ruby laser. So high power pumping is involved. So that is also very it is very costly to pumping the atoms from ground state to excited state. So those are the disadvantages of the ruby laser. Now coming to the part of applications. Applications of ruby laser, where we can use this kind of ruby laser. See. Okay, see. So these are some of the applications of ruby laser. So the ruby laser is majorly used in case of tattoos. Okay, in general, if you go outside, the tattoos can be used by using the ruby laser. The tattoos can be done by using the ruby laser. And in case of hair removal techniques, that is in case of cosmetic industry also we can use ruby laser. And holography. Holography is a best technique which involved the ruby laser. Okay, so these are some of the applications of ruby laser. Okay, Nana. Now coming to the next laser type, that is helium neon laser. So already we have discussed in case of different classifications of laser. So helium neon laser is a 4-level laser. So the energy levels are 4 energy levels which is having by the helium neon laser, and the output of the helium neon laser is a 6328 angstrom. The output wavelength of the helium neon laser is a 6328 angstroms. And next, helium neon laser is a gaseous state laser. This is what the gaseous state laser. The helium neon ratio is 10:1. Okay, the gas tube, the tube which is consisting of a gas mixture in a pressurized movement, that is the helium neon ratio is 10:1. 10:1 ratio we are using the gas mixture. And next, it gives the output wavelength in a continuous mode. But in case of ruby laser, we have seen that the output wavelength of the ruby laser is a pulsed laser. The output wavelength is a pulsed wavelength. But in case of helium neon laser, the helium neon laser is a continuous laser or continuous mode. And one more important point about helium neon laser is the first continuous laser was helium neon laser. The first solid state laser is a ruby laser. The first continuous laser is a helium neon laser. So now coming to the construction process of the helium neon laser. See. So the construction of helium neon laser. So here the helium neon laser consisting of a gas discharge tube. This discharge tube consisting of a gas mixture in the ratio, helium neon gas mixture in the ratio 10:1. Okay, so 1 bar of pressure means helium neon ratio in the ratio 10:1 means the neon atom is 1 bar of pressure and helium atom in the 10 bar of pressure, and this gas discharge tube is surrounded by the total this discharge tube is surrounded by the glass window. This entire discharge tube means the gas mixture is surrounded by the glass window, and in this case the inside of the gas mixture there is a pressure in the ratio 10:1. Okay, 10:1. This is the process of construction of helium neon laser, the simplified construction of helium neon laser. Now coming to the next point. So in case of helium neon laser, we are using the pumping process is the electrical discharge pumping. The electrical discharge pumping we are used in case of helium neon laser, and the active medium is helium neon laser in the ratio 10:1, and the host media is helium gas. Helium gas is acting as a host media. So this is what the process of helium neon laser. And already I told you the helium neon laser is a 4-level laser system. See here the energy level diagram of the helium neon laser. Okay, Nana. So this is the energy level diagram of the helium neon laser. So whenever the atoms are in the ground state, we are giving the energy to the ground state. Here the pumping process is a electrical discharge pumping. By using electrical discharge pumping, the atoms which are in the ground state can be excited to the excited energy states. The high level energy states are E2, E3 and E4 are the higher energy states. Okay, so here the helium atoms are very lightly in mass, means the helium atoms are very lightly atoms. So whenever you are using the electrical discharge pumping, simply the helium atoms are moved from one energy state to the another energy state. So here I would like to discuss some of the advantages of the helium neon laser. See, helium neon laser is having a very good coherent property. So one of the major advantages is the helium neon laser is having a very good coherent property, and when compared to other different types of lasers, the helium neon laser is very cost effective, means the cost of the helium neon laser is very low when compared to other different types of lasers. And next, coming to the another property, the construction of helium neon laser is not that complicated, not very much complicated. The construction is also very simple and the cost is very low, and it is having very good coherent property. And next, it is very safe also. The safety purpose also, the safety measurements also very good due to low power output. Due to low power output, the helium neon laser provides inherent safety. So these are the major advantages of the helium neon laser. So now whatever the laser may be, definitely there should having some disadvantages. Now I would like to explain about some of the disadvantages of the helium neon laser. Now see, one of the disadvantages is the output power is very low. Because of the output power is very low, it is very much disadvantages of the helium neon laser. And the output wavelength of the helium neon laser is a continuous laser. The output wavelength is a continuous wavelength in case of the helium neon laser. So this is about the helium neon laser advantages and disadvantages. Now coming to the application part. Okay, see, these are some of the applications of the helium neon laser. So the narrow red beam of the helium neon laser is used in supermarkets to read barcode readers. So in supermarkets we are using the barcode technique, is because of it is one of the application of the helium neon laser. And next, helium neon laser is used in holography in producing the 3D images of the objects. So to producing the 3D images of the objects, we are using holography technique. So this holography technique is also used by the helium neon laser. And next, helium neon lasers have many industrial and scientific uses, and also these are helium neon laser applications can also used in laboratory to demonstrate the optical properties, to demonstrations of the optics. So these are the major applications of the helium neon laser. Okay, so as of now we have discussed about the fundamentals of the lasers and various different types of lasers, basing on the output, basing on the energy levels, basing on the lasing action. Okay, now coming to the applications part of the laser. So what are the various applications we are using in lasers? Okay, so see, now I would like to discuss about the various applications of laser. So in case of defense and security, we are using lasers. In case of medicine, healthcare, in case of hospital also we are using laser applications, and the commercial and entertainment purpose also we can use the lasers. And next, scientific research also we can use the lasers. So now I want to brief each and every term. So see here, Okay, see here, lasers are used in many various fields. So one is manufacturing industries and medical applications and metrology, and next data storage. To storage the data also lasers can place a major important role, and communication purpose also we can use lasers. And next spectroscopy, microscopy, energy technology, military purpose also we can use lasers to detect the object, to detect the opposite ones. And next scientific technology, in case of scientific researches and technology also we can use the lasers. So first of all, in manufacturing industries, how we can use the lasers? See, in manufacturing industries, to processing the materials we can use lasers. So in case of cutting the material, cutting, welding, drilling and hardening and melting, so each and everything we can use this, means to cut the very hard materials we can use the lasers. The lasers are used to cut the materials, very hard materials, and to welding the hardening materials. And next melting purpose also we can use lasers. And photolithography technique also used by the lasers. And next 3D laser measurements, and next 3D stereolithography. So these are all the material processing involved by using the lasers. Okay, this can be used in case of industry purpose. Okay, these are the manufacturing industrial purposes. So in case of industry, in case of industries we can use the lasers like this: cutting, drilling, welding, hardening the materials. So all these purposes we can use the laser. This is what one of the first application of the laser. Now coming to the second application, that is in case of medical. In case of medical purpose also we can use the laser. How we can use laser in case of medical purpose? Okay, to surgery, the eye surgeries involved the eye. Okay, for example, see, this is what human eye. Okay, so we are sending laser beam. Here we are sending the laser beam into the human eye. So this is what, Nana, laser beam. We are sending laser beam into the human eye. Okay, this is what muscular degeneration. Okay, muscular degeneration. So without any blood drop, without losing any blood, we can do the surgery of eye by using the lasers. Okay, to cut the extra layer on the eye, we can use the lasers. And this is what, here the laser can detect the abnormal vessel growth. Here the abnormal vessel growths also can detect by the lasers. And next, coming to the another property of laser in case of medical, in medical process, in medical applications. So this is what neurosurgery. First one is neurosurgery, and next pneumology, and next gynecology, and next arthroscopy. But so all these different kinds of surgeries we can use the lasers. And lasers also can detect ulcers and tumors inside of the stomach of the human body. That is what endoscopic technique. By using endoscopic technique, lasers can detect the ulcers and tumors of inside of the stomach. Okay, this is what one of the major advantage in case of medical. So this is what the medical application of the laser. And also to remove hair removal techniques. Okay, to remove the permanent hair removal technique also can be used by the laser. Okay, lasers can be used to remove the hair. Okay, and next cosmetic industries also we can use the lasers by using to do the surgeries without any blood loss. To do the surgeries, lasers can be placed a major important role. Okay, and next treatment of ENT. Okay, so the treatment of dental decay. So the treatment of dental decay is also done by the laser. Okay, these are the all applications regarding to the medical. So this is what about the laser applications. Now coming to the next application, in case of military applications. So military applications of laser. In case of military also we can use the lasers. So lasers can by using the laser range finders, we can detect the object which is far away from the soldiers. Okay, for example, the laser range finders can detect the opposite one by using the laser range finders. Okay, so this is what one of the major application in case of military. And next, lasers are also used to dispose the energy of, see here, So the damaging of missiles of the opposite one can be detected by the laser range finders. Okay, this is also one of the major advantages, of laser. Okay, in case of military also we can use the lasers. And next here you can see the laser range finder. So this is what the laser range finder. Now already we have discussed in case of helium neon laser, one of the advantage of helium neon laser to scan the barcode reader, in case of supermarkets, that is also by using the lasers. Okay, and one more thing is data storage systems also the lasers can place a major important role. Data storage in case of bits or bytes, okay, whatever the storage may be, in case of storage of data, in case of computer applications we can use the laser. See, in case of high speed photography also we can use the lasers. Means the bullet which is coming from the gun, suddenly the bullet coming from the gun, that can be very clearly captured. The resolution of the peak is really captured by the lasers. Okay, high speed photograph, that is called high speed photography. And next, armor penetration and instant of fracturing. So all these can be done by the high speed photography. This high speed photography technique is done by the lasers. Okay, so this is what about the complete explanation of the lasers. So we can use the different already we have discussed about the different kinds of applications of lasers. So now students, you have understood where we can use the lasers, and first of all, what are the fundamentals of laser, what is laser and what are the fundamentals of laser, and what are the various different kinds of lasers we are using, and what are the different applications we are using nowadays. So that is what about my total video. I think you understood very well, and thank you very much for giving me this opportunity. So I am very thankful to Gurukulam for initiating all these kinds of different kinds of programs by the lecturers and students. I am very thankful, and I am also very grateful to be a part of Gurukulam. Thank you very much. Thank you Secretary Sir, and thank you Padmavati Madam Garu, and all the staff in the head office, and this is a very wonderful opportunity, and I am very happy to be a part of Gurukulam. Thank you one and all.